Hello?
Can hear you.
Okay.
This one is product rule. Differentiate. This is 4x squared. You differentiate this, you get 5.
Mm.
Where's the question? Where is the question? Oh, we do A. Okay, 4x squared, 5x plus 3. 4x squared, 5x plus 3. You differentiate which one? You differentiate this, you get 5. It's not
The bracket not got 1.
5.
The 5x plus 3. Not bracket, then power of
You
1.
differentiate this, you get 5. It's not 1. So this is 5. Differentiate 5x, you get 5. Differentiate 5x, you get 5. Then you keep, then this is correct. Then now you differentiate this one, you get 5 again. You get 5 again. Then you keep this. You keep this. Then you differentiate the 4x again. So there shouldn't be any 5 here. There shouldn't be any 5 here. There shouldn't be any 5 here. Because when you differentiate 4x squared, you get 8x. It's not 8. You get 8x. So this one shouldn't be there also. This one, okay. This one you keep. Okay, one more time. The first one you want to differentiate is this. Never mind, you differentiate this, you get 5. And this one you keep. Okay. Now the next one is you differentiate this. Differentiate this, you get 8x. You get 8x, not 4x squared. So no more already. Then you keep this. It should be 5x squared. So this one don't have. Right? Okay. One more time. Differentiate this. You have 5. This is 5, not 1. Then the 5 is not here. This 5 is there already. Now this one also shouldn't be here. Because now you have to differentiate the 4x squared. Differentiate 4x squared, you get 8x. 8x. It's not this. Then this one you keep. Okay, so you do again this one. Before that, I explain the next one first. Explain the next one. Next one is this. Okay. Okay, this one. Right? Same. Same. Because you see, in both cases, you have 4x squared, 4x squared. Oh, this is wrong. The one is 4x squared, the other one is 8x. You prefer, if you differentiate this one, then this is 5. This is 5. Then now, this one no more, this one no more. Right? This one you keep, you differentiate, this is not, this is 8x. Okay? So this only one question. Okay. So you try again and see this question. You try again, number 1. 5, 4x squared, 8x, 5 plus, yeah, this is correct. This 20x squared, 40x squared, correct. 24x, correct. So this is, take out 6, 6x, 6x. Take out 6x, you're left with 10x, take out 6x. Oh, correct, this one is correct. So you know how to do already, right? So I go on to more examples on the quotient rule. Okay, one more example on the quotient rule. Okay, the question is this: find the differential coefficient of fx equal to this thing. Now, you look at it. This one is the quotient rule. Okay, quotient rule, never mind. We know how to do quotient rule. But if you look at the factor at the bottom there, square root of 2x plus 1. We don't know how to differentiate square root unless you change it to the power of half, to the power half. So I change the square root of 2x plus 1 to the power half. When I change it to the power of half, I realize that it becomes a composite function. Okay, never mind. So I shouldn't be afraid, right? You just follow the normal way. Differentiate the top, keep the bottom, differentiate bottom, keep the top, then divide by the bottom square, right? Okay, so I differentiate the top, the pink color, become 1. The bottom is 2x plus 1 to the power half. So I copy back exactly what is the at the bottom there. Then I differentiate the bottom, minus, differentiate the bottom, you bring down half, this one, then the half minus 1. Then you have to differentiate inside the bracket, that is this one, 2. This one shouldn't make it. This one should be orange color, right? You differentiate the orange one. Okay, so you differentiate inside the bracket. You differentiate inside the bracket, you get 2. Then the x, you just keep. So now it looks like very complicated. This one is actually 2x plus 1 to the power half. This one, no need to write. But this one, I want to change it to 1. The denominator is 1. Why I want to put the 1 there? Because this negative half is actually belongs to the half minus negative 1. Minus 1 become negative half. Now this negative half is actually at the denominator. So this number x is at the top. This one is at the denominator. Now you see why I want to put at the 1 at the bottom here. The reason I put 1 here is to match this, is to add up this, How to add up these two? Have you come across this thing? Two fractions, AB, and another fraction, CD. You want to add them up, you have to cross A times D, then B times C, then the denominator is B times D. This one, can you understand this? This or no?
Yes.
This one. Yes, you know. Okay. Now I have AB, CD. CD. So I cross
The
this one.
one. Eh? Oh. I,
Anything is over 1. 10 is 10 over 1. 100 is 100 over 1. I create the 1 here so that I can match the two fractions together using this one. Any question?
no.
No. So now I match them. This times this. Power of half times power of half is power of 1. Power of half times this one times. This times this. Power of half times power of half is power of 1.
Not
Minus
1 times the 2x plus 1 power 1 over 2.
power 1.
No, the denominator 1 times the 2x plus 1 power 1 over 2.
A to the power of 1 over 2 times what is this? A to the power 1 over 2 times A to the power 1 over 2 is A to the
What?
power of 1. You add the two half together. Half plus half. Half plus half is 1. So when you multiply this half and this half, answer is 2 plus 1 to the power of 1. Any question? So this is my AD. This is AD. This is your AD. This one. This one is the AD. AD, AD. How you get AD? A times D. Okay, so far? Okay. So now the next step is B times C. B times C. This is B and this is C. 1 times X is X. Okay, so far? Then the denominator is BD. BD. This is B, this is D. B times D is this. Okay. Now this is at the denominator. This is at the denominator, so you put here. This one is originally there, so you put here. 2x minus x is x. 1 is 1. So this is the answer. Any question? Any question?
How the square root 2x plus 1 go down there? And then
Okay.
the top just
Okay.
left 1 plus x plus 1.
I know what you mean. I know what you mean. Right. Very good question. So we look at this. Look at this fraction. Thanks. Now we have another fraction. 1 over 2. Then over 3. What is this equal to? What is this equal to? Hmm? You see any difference between these two or not?
No. Oh, the equal sign, one lower, one upper.
Oh, correct. So how is it like that? How to do like that?
Okay.
This one is the longer one.
Mm.
Which one is the longer one? This one is the longer. This is the longer line. These two, this is the longer line. So for the top one, is 1 over 2, a fraction divided by 3. Okay, now for the
Mm.
bottom one, it is 1 divided by 2 over 3. They mean different thing. They mean different thing. So for the first one, it is actually 1 over 2, 1 over 2 divide by 3 means multiply by 3 over 1. Multiply by 3 over 1.
Mm.
This one is 3 over 2. This one is actually the top. The top is 1 divided by 3 over 2 means multiply with divide by 2 or 3 multiply by 3 over 2. This one means multiply by 3 over 2. Divide by 2 over 3 means multiply by 3 over 2. This is equal to 3 over 2. Although the answer is the same, this is divided by 3, sorry. Multiply by, sorry, this is 1 over 3. Divide by 3 is multiply with 103. 103. So this is 106. 106. Okay, no? You divide by the bottom one must terbalik. You divide by the bottom one must terbalik. So when you terbalik the 3 become 103. You terbalik the 203 become 302. So they are all different. They're all different. So when you look at this fraction here, this one can understand, huh? This one can or not? Can. So when you look at the bottom here, when you look at this one, when you look at this, the longer line will be this. The longer line will be this. This one, the longer line. This is the longer line. So this means that you multiply with the
2x plus 1 minus x. Okay. Divide
this one
the
is this case.
square root.
Is this case. This one is this case. The longer line is at the bottom. The longer line is at the bottom. So it is this thing multiply with this one. The bottom one is terbalik. 1 over 2x plus 1. That's how you get the 2x plus 1. Because this is the bottom one. You multiply this. Okay.
Then
now,
how about the x plus 1?
X plus 1 is this one. 2x minus 1 is x. Then the plus 1 here is the plus 1. Okay, now? This time, this type they are quite difficult, right? This type. When they involve square root, the power becomes a fraction. When the power becomes fraction, macam-macam boleh terjadi. Sometimes the term is at the top, sometimes the term is at the bottom, like this case here. It's quite difficult, right? So this is
The negative x minus 2x not become negative 2x2.
Which one are you referring to? This one?
The upper one, yes.
Okay. 2x minus x become x. Plus 1 is plus 1. This one, huh?
I thought the bracket 1 to times.
Which bracket 1 to times? Now, this one is actually at the top here. This one is actually at the bottom. At the bottom. At the top. This one at the bottom. Oh, this one. This one. This one, how to deal with it? This one, you have to take this, multiply with 1 over 2x plus 1. This one become here. That's why when you multiply this with 1, you get this. When you multiply this with this, you get this one. Okay or not? So far?
Okay.
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 Okay, then try to clear the explanation. Then we move on. We'll move on here. What is this? This is also the quotient. Quotient, this one. This is very complicated, right? 5A, 5H. Now, we look at 5, 5A, right? 5A. 5A is where one now? Okay. Disappear already. I delete off the question. Never mind. So I delete all this. Delete all this. There's the delete button. Delete. This one. Delete. This one correct already. Here, this one, right? So we are looking at number 5A. Okay, 5B we have done. Then the rest all didn't do yet. When you look at this, it looks like a quotient, right? But you can treat it two different ways. One way is you differentiate like a quotient. Another way is you treat it as a function of a function, right? So I'll explain the two ways to you, right? Two ways. Okay, the first one is this one, right? We treat it as a quotient. So I make two colors. The pink color is at the top. The orange color is at the bottom. Okay, right. So you differentiate the pink color first, you get 0. Differentiate a number, you get 0. That is the special case number 2 that I told you, you get 0. And the bottom, you just copy the same. The second one, you differentiate the bottom. Differentiate 2x, you get 2. Right? Differentiate 2x, you get 2. This is the first special case that I told you. You differentiate the 7, you get 0. The 2 plus 0 is 2 plus 0 is still 2. That's how you differentiate the whole thing. You get 2 there, right? Then the 3, you just keep the 3. Don't do anything to the 3. Just keep. So this one multiply with 0, the whole thing becomes 0. No need to think about this. Negative 2 times 3, negative 6. Then the bottom square. So this is the answer. Okay, this is the answer. And you can treat it in another way, right? I just copy down this for you. Right? I'll just copy this. I'm going to treat it in a different way. I'm going to treat it in a different way. Right? So this is the question. I'm going to treat this as three bracket 2x minus 7 So this one can be written in this form. At the bottom there, the power is negative. You remember? Okay, so you remember. Now, if I look at it this way, it is no longer a product of two functions, nor is it a quotient of two functions. No more like that. I look at it, there is only one function. The number in front is 3. 3 is a number you can just keep it, right? So dy over dx equals to this number 3 I just keep. The number 3 I just keep. Then this -1 I bring down. -1, 2x minus 7. What happened now? What is going to happen now? -1, -1.
Minus 2.
This -1 here is the original -1. Because of the differentiation, I have to -1 from the power there. Okay or not? Then I differentiate what is inside the bracket here. Differentiate what's inside the bracket, I get 2. Get 2 there. So when I multiply this number, 2, -1, and -3. 2, -1, and -3. What is the number I get? I get -6. I get -6. And bracket 2x minus 7. -1 minus 1 is actually -2. It's actually -2. But this is the answer already, right? This is the answer. This is the answer. But because the power -2, I can write it as this. -6 remain at the bottom. -6. But this power negative is actually belongs to the bottom. So it's 2x minus 7 raised to the power of -2. So the answer now is exactly the same as the answer that I have shown you earlier, right? Okay, right. So we look at this. We look at this question number 5a from 2 angles. The first one, the first one, I look at it as a quotient of two functions, 3 and 2x minus 7. 3 is at the top, differentiate the top, keep the bottom, minus, differentiate the bottom, then the top you keep, then divide by this bottom square. So I end up having -6x divided by 2x minus 7 squared. The square comes from the differentiation. Whatever at the bottom, we have to square it. Okay or not, this one?
Okay.
Then I look at this one. But this one, I can see there is only one function here. The top is actually a number, not a function. I mean, maybe you can look at it as function, but I look at it as a number. So I change the loop 3, I put 3. Instead of having 1 over 2x minus 7, I put 2x minus 7 to the power of -1. By doing this, it becomes a composite function to me. So if I want to differentiate it, I just differentiate a composite function. So 3 I don't differentiate. Bring down the -1. Then this thing -1 minus 1 some more. Differentiate inside the bracket, I have 2. So 2 times -1 times 3, -6. This one is 2x minus 7 to the power -2. You bring to the bottom. You see that the answer is the same. Answer is the same. Okay. So that's all. Only 2 minutes left. So only 2 minutes left. Cannot start a new question. So you continue to do this one. This one. You continue to do this. Question number 1 and question number 5. Right? We just sent to you already. You continue to do this. If you can finish before what is the next lesson? Friday or Tuesday?
Tuesday.